morning, everyone. My name is Sean Edwards. I'm the Chief Technology Officer here at Bloomberg. And it's my great pleasure to welcome all of you to the 4th annual Data for Good Exchange. This conference is about bringing data scientists from academia and industry together with public sector actors from nonprofits, government agencies, and NGOs in order to facilitate relationships between them and to solve the difficult problems that affect society. We're excited to see that the response to this important event grows stronger every year. We received more than 170 abstracts, papers, and panels submitted in the response for our call for speakers for this year's conference. That's almost triple the number of proposals that we got from last year. And we had over 1,000 people register to attend today's event on a Sunday, which is great. That says a lot about both the spirit of this event, which is meant to serve as a catalyst for the use of data science and human capital to solve the problems of social good, and its attendees. We host this conference with one single goal in mind: to encourage you to work together in applying modern machine learning methods to problems both in the public and nonprofit sectors. This event is a reflection of the corporate culture that Mike Bloomberg created and his philanthropic commitments to give back to the communities in which we work and live. To that end, we focus this year's theme on the conference: with great data comes great responsibility, on the challenge of ethics, or how data science can be applied to solve public interest problems without losing its soul. I now know that Spider-Man must be Gideon Man's favorite comic book hero. Throughout the day, you'll be hearing from people who are on the front line, where they are dealing with ethical challenges every day related to the application of data science methods to address challenges in the public and nonprofit sectors. They'll be sharing real examples about how to responsibly use data science in a public context, such as delivering city services, protecting children, meting out criminal justice, and avoiding data bias in public housing policies. Our two keynote speakers, John Kahan, General Manager of Customer Data and Analytics at Microsoft, and Sarah Tofty, Director of Research and Implementation at Everytown for Gun Safety, will talk about their use of data science to tackle two very different public health challenges: sudden infant death syndrome, or SIDS, and gun deaths. Please stick around at the end of the day for the networking and poster reception downstairs in our link. That's the large atrium that you just passed on your way up to the auditorium. Take advantage of the breaks and transitions between panels to network and build relationships with other attendees. This is how we help create an exchange of ideas, advice, and wisdom in applying approaches in data science to social good challenges. That's the exchange in Data for Good Exchange. I would like to extend a very special thank you to my colleague Gideon Mann, standing in the back, for originating this idea of this conference several years ago, and for leading its organizational efforts. Thank you to all of our speakers, to the members of the program and steering committees for the hard work, and most of all, to you, our attendees. We appreciate your dedication to making a difference in the world around us, and are excited to see what results from the connections that get made here today. After you leave here today, we ask that you share with us the collaborations that happen and the projects that move forward throughout the year. And we hope some of you in the audience will be up here on stage sharing your meaningful results at next year's Data for Good Exchange. Please enjoy the day. It's my pleasure now to welcome John Kahan, General Manager of Customer Data and Analytics at Microsoft, to the stage for this morning's first keynote. Welcome, John.
Thank you. Good morning. I'm very excited to be here today to take you through my journey to solve one of the most horrific mysteries of our time. I'm also excited because, frankly, I grew up in New York, and I'm happy to be back to New York. I spent the last 14.5 years on the West Coast, which is where I live today, but it's great to be back. I'll give you a little bit about my journey, my personal journey, my professional journey, and the things we're doing to stop SIDS once and for all. So let me start a little bit with my personal side of life. I grew up here. I have two parents that live with me in Seattle area. My dad was a judge and a mayor on Long Island. You can still see I continue to have my Long Island accent, which I'm proud of, and I don't like to lose. My mother was one of the first female executives at Ziff Davis, which became which was purchased by CBS during the publishing industry. And so I was born and bred here. But this is a journey that started only a short time ago. Let me start a little bit with my professional life. I worked for IBM for over 18 years, and most recently, in the last 14 years, I've worked for Microsoft, two of the strongest brands in the world and two of the strongest data companies in the world, particularly focused over the last couple of years on driving large-scale data, and I'm honored to do that for our CEO, Satya Nadella, and his senior leadership team. In that capacity, I drive their key measures around the world, their large-scale data that we use in order to make key decisions, in order to delight our customers and empower them, both their organization and individuals around the world. We instrument all of our products and our data at large scale. We bring that in every single day. In our systems today, we have over 1.5 exabytes of data, and we process several hundred petabytes of data every single day. So it gives you an idea of the size and scale of the organization. I run a data science team, an incredibly diverse, incredibly passionate data science team that comes to work every day trying to delight our customers around the world. In addition to that, I have a personal life. My personal life looks like this. I have 4 amazing daughters. My 24-year-old Emily, 21-year-old Sarah, my 18-year-old Leah, who I just dropped off to college, and my 10-year-old Sadie. And I'm mostly proud of the things that they have done, and they inspire me each and every day. And most recently, in the last 2 years, I was blessed with a grandson, which for me is a huge, huge thing, and you'll see why in the moments ahead. My grandson Kaiser is on the right side. So there's a professional and a personal life to this story that I want you to understand as I take you through this. It started about 14 years ago. 14 years ago, a little over 14 and a half years ago, I moved from IBM to Microsoft. The biggest professional move that I could ever done in my life, frankly, one of the best personal moves I ever did in my life. My wife was pregnant. She was an IBM executive at the time. We were both IBM executives. I ran the integrated marketing communications for sales and distribution for IBM. And my wife ran Linux development, mainframe development. And we were trading kids in airports, as you can imagine. That's always a challenge. And our 4th child was due. And 14 and a half years ago, October 3rd, our son, Aaron Matthew, was born. This picture was taken shortly after he was born. And everything was great. It was an amazing experience. I mean, you can imagine, especially being a Jewish boy from New York, having a son after 3 daughters was a huge deal. Everybody was going nuts. My parents, my grandparents were excited about this. Everything was perfect. And then 6 hours later, tragedy struck. Even after 14 and a half years, I still get choked up by it. The reality is Aaron stopped breathing. They took him to Seattle Children's, which is it's one of the best pediatric research centers in the world. And they worked on him for several days, and several days later, Aaron passed away. And he passed away from something that is probably the worst thing you could tell a human being. He passed away from something that we do not know. We don't know to this day why he died. And that's where my journey began. So what do? You do what you normally do, which is you pick up your pieces, you try to figure out why, make sure your kids are safe, your family's safe, and you move on. And you write checks. You write checks to charity, and you try to give back a little bit. And you look for answers. But mostly you move on with your life. And that's what I did. I moved on with my life until about 1.5 years ago. About 1.5 years ago, I was looking at this amazing picture of my second daughter, Sarah, hiking in New Zealand. It was beautiful, and I'm a photographer as a passion of my life. I love photography. And I thought, I could do that. I could hike. But you need to understand, like, I grew up in New York. Me, roughing it is the Marriott Courtyard. Hiking is not like the way I grew up. This is not like something, like, I don't know where this came over me, but it was like, I'll do this. And I'll set a set of goals, and I'll try to move forward on this. And my wife said, well, why don't you do it for a cause? It wasn't something that I came up with. She said, why don't you do it for a cause? And I said, yeah, I'll give money to Seattle Children's where they helped us. And we started giving money to Seattle Children's, and we started raising awareness of this, and I started learning. And I'm going to tell you a little bit about the learning first and the data behind this, because it's astonishing to me. Let me start with a question. Where do you think the US infant mortality rate is versus the rest of the developed nations in the world? How many people think that our infant mortality rate, with all of our wealth, with all the research, with the amazing researchers and data that we have, is ranked? Is it high? Is it medium? Is it low? High meaning, raise your hands if you think our infant mortality rate, meaning that infants in the United States survive longer than other countries. Raise your hands high. How many people think it's about average? Raise your hands. And how many people think, no, 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 we are more like low end? Raise your hands. This is an astonishing fact to me. The US infant mortality rate, based on the Organization of Economic Cooperation and Development, ranks 32nd of the top 36 developed nations in the world. We're not talking about Afghanistan. We're not talking about Pakistan. We're talking about Germany and France, major developed nations in the world. 6 of 1,000 children die before their first birthday in the United States. This is an astonishing fact that I learned along my journey. 6 of 1,000 children do not make it to their first birthday. This is not SIDS, this is just the overall mortality rate of infants in the United States. This is awareness that we need to make sure people understand so that we can solve these challenges. So where does SIDS fit in? SIDS is the leading cause of death for children from 1 month to 1 year old. What that means is 1 of these 6 children that die before their first birthday die of unexplained causes. And half of them have had an autopsy and they still don't know, and that's what they call SIDS. But unexplained causes, which means 1 of 1,000 children in the United States die every year, and the doctors don't know why. So let me kind of boil this all down to you. Make sure you understand what this all means, because it's incredible that people don't understand that this problem is a big problem that we need to solve. This means since we lost Aaron 14 years ago, 56,000 children died in the United States, and we don't know why. Their parents don't know why. Their grandparents don't know why. Their brothers, their sisters, their friends and family do not know why. To boil it down further for you, it's the equivalent of taking 3 busloads of children every single week for the last 14 years and removing them from the face of the earth. And we don't know why. This is a big problem. It's a problem that we cannot let these children go and not figure out why. But is it getting better? Have we improved over the years? That's the other key interesting fact that comes along with this. The good news is, back in the early 90s, there was this drop that occurred on a correlation. And as most of you are data folks, some of you are not, correlation doesn't mean causation. But there was a very interesting study that determined that there's a correlation that if you take a child and you put them to bed on their back, they have a lower risk of dying of sudden infant death syndrome than if you put them on their stomach. It does not mean that it's a full causation, but it's a correlation. This is likely the cause of that drop that occurred in the mid-90s. In addition to that, that is likely the drop of smoking and the reduction of smoking. So it appears like it's going down, but it's a classic data problem. When we talk about classic data problems, we talk about misclassifications of data, not understanding data clearly. So let me explain. This problem is not actually reducing. It's actually a problem in classification. Unknown is rising during the same time period. The only difference in unknown and SIDS is that we ran an autopsy or we didn't run an autopsy. In both cases, we don't know why these children are dying. And then the third cause is we found the child in bed and we ran an autopsy, or we didn't, and we still don't know. And all combined, the rate has not improved since the mid-90s. The fact is, we still lose 1 in 1,000 children in the United States every year, 3 busloads of children, and this has not improved since the mid-90s. And as far as I'm concerned, this is unacceptable. It's unacceptable not just for the parents that lost children like myself. It haunts all parents. It haunts every new parent. It haunts every new brother and sister. It haunts every new sibling that their child may be next, and we need to figure out why. So there are some barriers to success here. And there are things that we need to do in order to attack this problem head on. First, there's a huge awareness problem. That's why I'm here today. It's the reason I'm excited to come here today. As with any speaker, I'm always a little nervous when I first come up, and I'm thinking, how am I going to get across the importance of this? But this is a big awareness problem. And awareness leads to funding, and funding leads to research, and research and data lead to answers. It's really that simple. If awareness is not well understood that this is a problem, then guess what happens? The government says, I'm not going to fund the research. Private corporations and researchers decide to go work on other problems. And there are big problems in the world, don't get me wrong. And we have to prioritize our time. But let me tell you, the loss of a child is by far the most painful experience you could ever wish upon anyone in the world. Data is a big challenge. Data, excuse me, my New York accent always comes out. I'm always proud when I can come to an audience and I can use my New York accent and people understand me. I still use data. It's kind of interesting. Data. Data is a challenge. We have these incredible privacy laws in the United States. It's great how we protect individuals. But in the process, we are hampering our researchers. Microsoft created, and we released it, it's open, a concept called differential privacy. Differential privacy is a way to create mass understanding of data while protecting the individual. It's a technical technique that researchers created. Facebook uses, Google uses, Microsoft uses, and many other companies use in order to protect the individual. That's how I can study 2 billion people on the planet running Windows every single day, but never identify the actual individual. That's how I can bring all that data in and really understand them and delight them every day with new delivery. These techniques need to become part of our CDC data and all the data that we have in the United States, and we need to unleash the power of this data to our researchers. Skills. Skills are an amazing thing. We are not medical researchers. I do not run a medical research team. To me, it's all dots, ones and zeros, and rows and columns. Tell me the codes, and I'll tell you what's correlated and what's not. That's what we look at. But combining the power of big data skills, and I run a team of probably the most passionate, diverse in nature data scientists that you've ever seen in the world, and combining that with medical researchers unlocks power that we've never seen before. And I'll talk a little bit more about that in the future. Community. Unlocking things in community is a big deal. Getting people to work together, and then last, working with government. So I started on my journey. Originally, I said, hey, you know what would be really cool? If I could hike 100 miles and 13,000 feet of elevation gain, 1 mile for every year my child was born. I've recently raised that to 1,000 miles and 100,000 feet. And last week, I passed 600 miles and 130,000 feet of elevation. This is a picture of me on top of Mount Kilimanjaro, which is the highest freestanding mountain in the Western Hemisphere. By far the most difficult personal thing I've ever done mentally. It's a statement to go and raise awareness and funding. That's all it's about. I released 2 books, one and then there's a second one which will release this week, one on the Arctic and one on Antarctica. I've traveled to every continent in the world. And these are photography books of my passion, where all money goes to this cause. I've lobbied government for change, to unleash data, to open up data, to make it easier for data scientists and researchers to solve these problems, to be able to use these kinds of techniques. And then a miracle happened. Not something I started, not something I asked to do. This diverse team of data scientists who come from fields such as economists and mathematicians and statisticians, not the traditional data scientists who come through just a computer science major, although a bunch of them have it. Physicists and astronomers got together with Seattle Children's, and a miracle happened. All of a sudden, they realized that their skills and solving things like, hey, are our customers happy with Windows, could solve, hey, can we save a life? And bringing the two together. And in fact, the exact same techniques are used, and I'll show you what that means, with world-class medical researchers in Seattle Children's, and most recently from a number of other world-renowned institutions that all are behind these SIDS efforts. We started with a data set from the CDC. For us, it's a tiny little data set, a few hundred terabytes of data. For medical researchers, it was a major blockage. I mean, what you saw on that screen, 250 columns to a medical researcher that works on sample sizes of 30, and in most cases works on animal models, is like, talking another language. And so we took all this data, and thank you, CDC, for making it available. Frankly, we need to do more. We need all the state registries as well, which are blocked with the bureaucracy that our government puts in place, thinking we're protecting individuals, and instead we're hampering our ability to save lives. And we put them into a model. This is actually a Bayesian network of all of the correlation factors of those things. From this, we can understand what's correlated to what's strong correlations, where the first elements are, what's the second elements, what's leading to another. We can hold things constant. This thing was released to all these researchers, and immediately we passed a milestone, which was we could show them all their theories in the data that was available to them, either proven or not. And we opened up new correlations and new approaches to what we're doing. And so you see what we've done is taken the data and put it in the cloud in Azure, which Microsoft Philanthropies donated, and all the capabilities associated with it. We put it in our Power BI backend, and you can execute, and the researchers can execute with a click. A researcher can make one click and see their thought processes across the board. When we move from this to where we're going, the second level is personalized medicine. When a child is born, you get an APGAR score. An APGAR score basically says, hey, how healthy is the child? But can we apply the data to a doctor that could sit there? And what you see here is actually a live data that allows a doctor to be able to say, hey, if I click and I say the mother is this age, they smoke, they have a father that's this age, they have had prenatal care at this part of the thing, what is their SIDS risk rate? And we're delivering these kinds of capabilities now to doctors to be able to work with mothers and fathers to be able to reduce the SIDS rate. But we're taking it further. Last week we announced we're going to build the first genome database of SIDS children. We're going to do DNA on all the tissue samples we can get our hands on in the United States. And the thing that I didn't know was Aaron's tissue sample was still available. And so they're going to run a DNA. The first one will be done on my son over the next 2 weeks. And we will build a data set that doesn't just have self-stated data, but it has true DNA data that we can connect together at large scale that all researchers can go after. And it is through the power of this data that did not exist 14 years ago. It's an amazing thing, but the tissue sample of Aaron still existed in a tissue bank somewhere in Iowa that they found. And now they can run DNA samples against it. We can connect it to all this data, and we can understand what is going on with this mystery and solve it once and for all. And we've already uncovered a number of correlations that were not found before. Things such as prenatal care. We argue in the United States over healthcare, and it's a crazy thing. But you know what? If a mother doesn't go to prenatal care in the first trimester, their SIDS risk rate goes up 50%. And if they don't go up in the second trimester, it grows up even higher. That's not saying that it's a cause. It's likely a correlation of other things, such as the talking about smoking or prenatal vitamins or taking care of themselves. It is likely related to another factor. But the reality is we understand now more in the data in order to solve this than we ever have before. So let me end with a video from on top of Mount Kilimanjaro, where the oxygen level is 50% of what you hear today, what you have today. It'll give you an understanding of how hard this journey is and how important it is.
I'm going to read this because I'm going to get emotional. To my friends and family, today marks a milestone in our journey to stop sudden infant death syndrome, otherwise known as SIDS. As many of you know, I've been hiking against the goal of 100 miles to raise awareness and much needed funds to stop SIDS. Today, I stand here at the peak of Mount Kilimanjaro, some 12,341 feet above sea level, the highest mountain in Africa, the highest standing mountain worldwide. I've hiked over 35 miles over the last 6 days and 125 since I set the goal of 100, easily outpacing it. However, this is just the beginning. Much has to be done to find out why so we can stop SIDS. A huge thank you for all your support throughout the year and for opening up your hearts and most importantly your wallets to stop SIDS. To my wife Heather, there's no way I could have done this without you. The last 13 years and our whole life is behind you, is behind me because of you. And to my children, Emily, Sarah, Leah, and Sadie, and my grandson, Kaiser, you inspire me every day to do better things. And my teammates at Microsoft, the most generous, kind, best people in the world, working for one of the best companies on this planet. A huge thank you. And to my data scientists who are diving in with Dr. Rubens to figure out why. I don't know how to thank you enough. God bless. Please give. Give for Aaron. Give for all parents. Give to stop SIDS. God bless. Thank you.
Let me end with this. A huge thank you. Thank you for listening to my story and my journey. I won't stop until we have an answer to this. This is my personal mission. The feeling that I have today is the same feeling I had 14 and a half years ago, except I'm incredibly energized. I have a team behind me that represents some of the best talent in the world. Not just the ones at Microsoft, but the ones across all of the medical researchers around the world. And together with all of you, as you start thinking about the things that you want to do in life, please take note of this. This is a space that can help all of us. Thank you very much.